don't need your Chromebook open. You can close that now. Have your note packet out. Right here. Okay, we're going to move on to day 2, which is a lot of vocab. Okay, kind of conceptual today. You lost your note packet already. There's extras in the bin. Okay. Okay, so we're going to be talking about terms that are used to describe the center and spread of data. The mean of the population is the average. Of the entire population. And we use this symbol. It looks like kind of like a crazy U kind of symbol, and it's pronounced mu. Mu. Okay. The mean of the sample would just be the average of a sample. So part of the population, whatever part you are sampling. And we use X bar to describe that. Okay, standard deviation is the measure of how spread out the data is from the mean. The measure of how spread out the data is from the mean. And if we're talking about the standard deviation of a population, we use this, like, it looks like a circle with a little kind of hat thing on it. And it's called sigma. Okay, and then this is the same standard deviation. You're just dealing with just the sample data, and you use S. Just S. Normal S. Okay, so we got mu and X bar, meaning the same thing. They both mean the mean or the average, but this is for the population, this is for the sample. And then sigma and S mean the same thing. They're both standard deviation. This is for the population, this is for the sample. Okay, questions there? Okay, flip it over. The normal curves A, B, and C represent battery lives of the population of cell phones of comparable models of 3 different companies. So this is continuing on from Friday's notes. Okay, and then if we want to mark the mean, it's right here, okay, in the middle. Okay, so 3 different companies. This is the data. Do they look like normal curves? Remember from Friday what normal curve means? Yeah, they're bell-shaped. One's just, skinnier and some are fatter. Okay. It says if the standard deviation for those companies are 0.1, 0.4, and 0.5, identify which of these standard deviations corresponds to each graph above and describe your reasoning. Okay, so remember the standard deviation is how spread out the data is from the mean. So the lower the standard deviation, the higher the curve and the more data that's close to that mean. Okay, and so this 0.1 should go with curve A. And again, that's because most of the data falls very close to the mean. It's not spread out. Okay, it's all very close to this average, all in the middle. Okay, so you could say because the data is tightly clustered around the mean. Okay, so if that's true, what standard deviation do you think goes with C? 0.5, good, because that's the furthest apart. And then the 0.4 must go with B. Okay, so the more spread out you are, the higher your standard deviation is going to be. Questions on that? Okay. Here it says normal curves D, E, and F represent battery lives of cell phones for 3 different companies. Compare the means. So the mean is the middle of the curve. Okay, so D's mean is here, E's mean is here, F's mean is here. So do they have the same mean? No, because it's some are lower, some are high, right? So D has smallest mean. It's the lowest. F has the highest. Okay, the standard deviation is how spread out from the mean the data is. So D's, this is the spread of D. That's how spread out it is from the mean. E and F. What do you think about that? They're the same. Good. Yeah, they have the same standard deviation because they're this kind of the same shape. They're the same spread out from their mean. Okay. Says the standard test scores at Washington Elementary produced a bell-shaped curve. The mean score was 83 and the standard deviation was 4. The standard test scores at Hoover Elementary School produced a bell-shaped curve, but the mean score was 85 and the standard deviation was 2. Sketch the normal curves to represent these scenarios. Describe how the shapes of the normal curves will be similar and different. Okay, so if we look at, let's make one for Washington. It said the mean at Washington was 83. So put that in the middle. Standard deviation is how spread out from the mean this is. So every time I go one standard deviation away from the mean, I'm going to either add 4 or subtract 4. So here I'm going to add 4 to 83 and get 87. Here I'm going to subtract 4 from 83 and get 79. Okay, then you're going to keep continuing that pattern. So if this is 87, if I add 4 to 87, I'm going to get 91. If I subtract 4 from 79, I would get 75. And then we usually go 3 standard deviations out. So I'll go one more. So if I add 4 to 91, I get 95. And if I subtract 4, I get 71. Questions on how that's set up. This being your mean in the middle. Okay, you guys draw one for the Hoover Elementary. We already filled out for them.
It's got like
Oh. Okay, so what should go in the middle of this Hoover Elementary School script? 85. And then the next one higher should be 87. And then the next one higher should be 89. And then 91. And then lower 83. And then 81. Then 79. Good. Okay, so we could talk about these. Which school had the higher mean or the higher average score? Hoover, right? Because the mean here is 85 and the mean there was 83. Which school would have more students testing closer to the mean? Why is it Hoover? Because, good, the standard deviation is smaller here than it is here. So that means more students are testing close to that average, right, at this school compared to that school. Questions on that? Okay, flip it over. We have some other terms that we use to describe normal curves. Okay, we use this SOX acronym to remember shape, outlier, center, and spread to describe the normal curve. So shape can be like symmetric. We can use bell-shaped to describe a normal curve. Or we can say it's skewed left or skewed right. So these are kind of examples that you might see. Skewed left and skewed right are a little bit backwards of what you would think. Skewed left is where most of the data is actually on the right side of the graph, so it looks like that. And skewed right is where most of the data is on the left side of the graph. Okay, so they're kind of like backwards. And it has to do with the mean and the median, how the mean and the median compare to each other. We won't get too much into that. Okay, we mostly in this class work with normal curves, so symmetric and bell-shaped. Okay, an outlier is a data point that is distinctly separate from the rest of the data. Okay, it's like real far away. So everything's kind of hovering around, 80 range, and this outlier is like 2. Some scores like a 2. Okay. Center is when you're talking about the normal distribution, it's the mean. Okay, so it's the mean when we're talking about normal distribution, which we are here. Bless you. Okay, and then the spread is how stretched or squeezed, I'm going to use that word, squeezed a distribution is. Okay, we usually use range to describe the spread. So range would be like our data goes from 2 to 100. Okay, or our data goes from 5 to 80. Okay, that's like a range. There's a lot of different ways to describe the spread of data, but we usually use the range. Okay, so let's look at 11. How would you describe its shape? Good, it's bell-shaped. You could say it's symmetric. It is symmetric. Do you think that there's any outliers, like where they're way far out? No. Okay, what's the center? 200 pounds. And the spread, so we're going to use the range to describe the spread, goes from what to what? Good, 100 to 300 pounds. Okay. How far up it is? Yeah, that's kind of confusing. So usually range, like domain and range, that would be like this way. But we're not talking about that kind of range. We're talking about like how far they're apart. Yeah, because this isn't really X and Y. Well, it is. Yeah, I know how that is kind of confusing. It's like a different way of using the word range. More like how you'd use range in everyday life. Okay, good. 12. Shape. Bell-shaped. It's pretty bell-shaped, I'd say. I don't. It has to be really skewed left. It has to be like where a lot of the data is over here. Like more like if it would be shaped like this. Okay. I think it's pretty bell-shaped. Outliers. I don't think we have any major outliers here. Center. Where do you think the center is? 55. Pretty good. Okay. Spread. 0 to 100. If you had said like 10 to 90, that would be fine too. It's kind of like up for interpretation there. Okay. Questions? Okay. I'd like you to get with one other person and then take out a Chromebook for only one between you and the one person. If you're in a group of 3, you can just have one Chromebook for 3. That's fine, but just make sure everybody can see it. Okay, so if you're in a group of 3, make sure everybody can see the screen of your Chromebook, so you might have to move a little bit. Go to student.desmos.com, type in RUE8T, I think space ATM.